Hi, my name is Omar Mamdouh. This is video for the first task in grep tasks. Let's begin. Our task is to predict student scores based on the number of studying hours using a simple linear regression model. First, importing our data using read.read_csv method from pandas module and saving our data to our pandas data frame, naming it student scores. Then we need to explore our data to see our first 5 observations in our dataset. We use .head method on our pandas data frame. We see here our first 5 observations of our dataset. We use .info method. We see here we haven't any missing value and we have 25 entries for 2 variables, hours and scores. Hours is float and data type of scores variable is integer. So we need to make some exploratory data analysis to explore data more. First, quantitatively, we need some descriptive statistics to describe our data. We use this .describe method on our data frame object student scores, and seeing that we have 25 entries and the mean for hours is 5, for hours variable is 5, and the mean for scores variable is 51. We see that standard deviations for hours variable is 2.5 and for scores variable is 25.28, and the range for our hours variable is from 1.1 to 9.2, and the range for our scores variable is from 17 to 95. Then we use the correlation method on our data frame object to get our correlation matrix for our dataset. We can see that there is high positive correlation between the 2 variables in our dataset, hours and scores variable, 0.976, so we can predict each variable by the other. Statistical note: correlation not mean causation. Then we can plot our observation on the scatter plot, hours on the x-axis, scores on the y-axis. To implement graphical EDA or graphical exploratory data analysis, we need mathematical function mapping our feature variable hours to our target variable scores. We can see visually that the relationship is linear, and we need linear equation to fit our data. First, to split our data to training set for fitting the model and to testing set for evaluating our model. By train test split function from sklearn.model selection module, then we instantiate our linear regression model object, fitting it on our training data. After training our model, we reach to model best fit our data, so we can plot it on the last plot by extracting the slope of the line and the y-intercept of the line from respectively dot coefficient and dot intercept attributes of our model. We have now our linear equation. We can plot it by using dot plot method on our object PLT. We see it fits our data. Finally, we need to use our model for prediction using .predict method on our regressor object. See, here's the difference between actual values and the predicted values of the model using our testing set. Now we can evaluate our model using mean absolute error metric from sklearn.metrics module, passing our target values from testing set and our predicted values of our model. We get 4.13. We can evaluate our model also by .score method on our regressor object, and we get 0.93. What will be predicted score if a student studies for 9.25 hours a day? We have now our predicted value by using .predict method on our regressor and passing it 9.25 hours as a value for our feature, and we get our target variable as 93.89. So we have predicted score for student studies for 9.25 hours a day is 93.89 score. Thanks for watching.